So now we're talking about the discriminant and its properties, and the discriminant is really a part of the quadratic formula. So let's take a look at one of our problems. We'll start with problem number 9. This is from the back side of that worksheet, and it says, find the discriminant, tell how many solutions that has. So we're using this information, and we're going to have to evaluate the discriminant. Well, the discriminant is really just what's under the radical in the quadratic formula. It's that b squared minus 4ac. And we can figure out if we have one solution, two solutions, or no solutions, or two imaginary solutions by evaluating the discriminant. If the discriminant is positive, you get two real solutions. If the discriminant is 0, then you have only one solution. And it's one real solution. And the discriminant is negative, then you have two imaginary solutions. And I'm just going to write real right here because this is a one real solution. So let's go ahead and evaluate then the discriminant for this quadratic here. So the quadratic has to be in standard form, ax squared plus bx plus c equals 0. And this one is already solved for 0 for us, which is very nice. So let's go ahead and identify what our a, b, and c are then. Our a value, which is in front of the quadratic variable, is just 1. Our b value, which is in front of our linear variable, which we don't have one, so our b must be 0. And then our c value is our constant, which is negative 9. Let's go ahead and we can plug these things into the discriminant, b squared minus 4ac. So b squared is 0 squared minus 4 times a, which is 1, times c, which is negative 9. Well, 0 squared we know is 0. And here we have 4 times 1 times negative 9. Well, 4 times 1 is just 4. And 4 times 9 is 36. Now this is a negative 36, but we have minus negative 36, so it becomes plus. So here we find that our discriminant value is actually 36. And we go back to our chart over here and we think, oh, what do we have? A positive, a 0, or a negative? Well, I've got a positive number, which means I have two real solutions. Okay, let's try another problem. Number 14. We take a look here. It says negative 10k squared minus 3 equals negative 5k. The first thing that I recognize is that it's not in standard form. So I want to solve to make sure that it's equal to 0. So I'm going to go ahead and add 5k to both sides. And when I do that, I'll get negative 10k squared. And I'm going to write this in standard form right away. So I'm going to put that plus 5k right in the middle, and then minus 3. So I have a, b, and c. And that should equal 0. So my a is negative 10, my b is 5, and my c is negative 3. Let's go ahead and plug that now into the discriminant. The discriminant is b squared minus 4ac. So b squared is 5 squared minus 4 times negative 10 times negative 3. So 5 squared is 25. And here I have 1, 2, 3 negatives, so my answer will be a negative number. So negative 10 times negative 3, that's a positive 30. And a positive 30 times negative 4 is a negative 120. Finally, I do 25 minus 120, and that gives me a negative 95. Negative number. Well, if I think back to my chart, a negative number had two imaginary solutions. If you have any more questions about the discriminant and its properties, go ahead and talk to me or Mr. Daniels. The whole reason that we do discriminants is that we want to be able to cut down on some time. So if we can figure out if we have any solutions and what the kinds of solutions they are, we may not be looking for imaginary solutions. We may be only looking for real solutions. And if there are real solutions, then we would go ahead and do this quadratic formula after figuring out the discriminant. But if we find right away that there's imaginary solutions, then we're not really interested in doing the quadratic formula a lot of times, depending on the situation. Again, have any questions, see me or Mr. Daniels, and have fun doing your homework.